Good morning. My name is Alberto Claveri. I'm the segment manager for industrial market in Aliaxis, Italy since 2019, after having been the product manager for instrumentation for 10 years. Today, it's a pleasure to introduce you a project that supports a strategic topic that is to recover value from garbage. We know that the planet is getting more and more crowded, and so all the human being activities generate rubbish in solid form as well as in liquid one. These last 10 years, the amount reached a critical level, awakening a sense of duty for a cautious management of garbage. The process of the rubbish management is quite long, starting from a correct delivery up to its final disposal, trying to maximize the amount of recycled material. This is a challenge for sure, is the challenge of generating value from rubbish. And it's in some way an idea to transform a problem in opportunity, chasing in some way the myth of Midas king who converted in gold everything it touched. To be more precise, today we are going to see a project related to the precious metal recovered from e-waste, but I think it's important to get a clear picture about the scenario that we are facing. Every year, 54 million of tons are generated worldwide, and the European contribution is set at 13 million of tons. So really a huge amount of e-waste. But what is e-waste? E-waste is the mobile phone that you have in the pocket, is the laptop that you are using to follow this speech when they will get aged, as well as all the electronic devices that you use every day. The increase by year is set at 10%, expecting to reach 74 million of tons at the beginning of 2025. Who are the main contributors? Basically, United States, where the contribution is quite stable. Europe, in this case, the deployment of new guidelines and new regulations is helping to maintain and to reduce a little bit our contribution. China, where instead the contribution is increasing a lot, and let me mention also India among these countries. What are the main sources? For sure, the urbanization and the correlated industrialization, not forgetting the disposable products, and considering also the high innovation pace that is placed for electronic device. In Europe, we are quite well educated and sensitized in this problem, and so we are able to recover 33% of the e-waste through the precious metal recovery process. The process that we are going to see is the complete renovation of a plant dedicated for precious metal recovery, and the metal extracted are different: gold, platinum, palladium, rhodium, ruthenium, and iridium, in addition to copper, nickel, and also tin. Just to have an idea about the potential of this business, from 1 ton of e-waste, we are able to get really a high weight of precious metal, and the value is around 10,000 euros. In particular, we are able to get more than 250 kilograms of copper, more than 40 kilograms of tin, and again, also for what concerns the silver, more than 600 grams, and almost 250 grams of gold. Which is the process? The process is a hydrometallurgical process that can be divided in three different stages. The leaching process. After that, there is the concentration purification of the solution. And finally, there is the metal oxide recovery. The leaching used for this plant is by percolation, but can be used also a similar process under pressure or in vacuum. For what concerns the concentration, we use the precipitation, the ion exchanger, but also the reverse osmosis technology can be applied to do that. And then finally, the metal recovery by electrowinning or by gas reduction. As gas in this case is used hydrogen. Just to understand better the process flow, it's quite simple, starting with a mechanical pretreatment in order to fracture the PCB, the e-waste. This is a process that can help to increase the the contact surface of these parts with the acid leaching, increasing the efficiency of the process. Then there is a separation of solid fraction by the liquid one, and we can start to get the gold and silver, basically. Then the solids are furtherly fractured in order to, again, increase as much as possible the contact surface, and again, we can proceed with acid leaching. All the fraction, liquid fraction, are gathered, and so we can proceed with the electrodeposition, the electrowinning, so the electrical chemical process that can help to make them more pure. As you can see, many aggressive chemicals are used: sulfuric acid, chlorhydric acid, nitric acid. So for sure is we are speaking about aggressive fluid. The process conditions are not so demanding. We can go on introducing the player of this project. Let me mention the project leader, that is Safimet. Safimet is a company focused on refining of precious metal, services that are offered to goldsmiths, but also to all the companies who are dealing with PCB and with galvanic processes. On the other side, the business partner is Aliaxis Group, a well-known international group who produce innovative thermoplastic system for fluid conveying, present in more than 40 countries with 100 different branch manufacturing unit or commercial branches, offering and employing more than 15,000 people. Let's go on diving deeper on the dynamic of the process, starting defining the needs of the project leader, Safimet. So they were looking for a reliable supplier for thermoplastic systems, as we have seen that the really aggressive chemicals are applied for this process. Plastic is for sure the best option, but they were looking also for a company that was able to supply consultancy, so to make an analysis related to the chemical compatibility in order to define the best thermoplastic solution, offering high performances in a safe way for a long time. So we offered obviously these services, and we supplied them polypropylene valve and fittings, PVDF and CPVC valve fittings and pipes, and also PVCU valve and fitting. In each story there is a protagonist, as well as in each project there is a key product. In this case, we decided to select the DK. The DK is a diaphragm valve, a very special diaphragm valve. This case flanged and in PVDF. The monolithic body reduce the hazard for operator for the environment. A seamless internal profile provide a service, a self-draining effect that can prevent from corrosion. Then the optimized fluid dynamic design, thanks to special internal shape of the body, can reduce the pressure loss, and more than 300 different positions of the membrane can simplify the procedure to find the proper hydraulic balance. Available in different thermoplastic material, CPVC, UPVC, PVDF, polypropylene, with different process connection. In this case, we mentioned the flanged one in both main norms, so ISO and ANSI. I hope you appreciated this really short speech and this presentation. I remain available for who can be interested to know more about this process, or in case someone wants to share his personal experience. Thanks a lot for the attention. Let's stay connected with us, since the next speech led by Mr. Antonini will be really interesting, and again supporting this important topic of recovery value from garbage.